I want to talk about how we can do a related rates problem with polar equations. So a particle is moving along that curve with dr dt equal to -3. So the rate that it's moving on the radius, so this would mean, of course, it's kind of moving in the opposite direction as its normal r at this particular rate. Find the value of d theta dt, the rate the angle is changing, at theta equals pi. Okay, now I always use the same kind of step-by-step process for solving a related rates question. I start with, I want to draw a picture. And in this case, of course, it's just going to be a picture of this particular equation. So here it is. Here is r equals 3 sine 2 theta. Now, in this case, I don't know how useful this honestly is, trying to figure out, well, where is pi, as it's kind of going through here, where is that particular spot, putting this in here, this rate at that particular moment. I'm not sure, but I do always like to have a picture to kind of think about. The next thing is I like to write down the rate that I know. I know that dr dt is equal to -3, and I like to know or write down the rate that I'm looking for. I'm looking for this. Now my next step is to find an equation that relates these rates to each other. And this is sometimes tricky. This is a normal related rates, typically has some kind of geometric formula, maybe Pythagorean theorem or a volume or something. But in this case, we have an equation given to us that relates these rates. It's this one right here. Okay? These variables are related by this curve. So that is my equation. I'm just going to write down, all right, r is equal to 3 sine of 2 theta. Now, I'm going to find the derivative of that. That's my next step. Now, just as a quick kind of reminder, if I were to find the derivative of r, you would notice that theta is my variable, right? The derivative, theta is the variable, so how r is changing with respect to the angle. But that isn't the rate I was given. I was given dr dt, and to convert it, we simply multiply by d theta dt, and then that gives me the rate that I'm actually trying to aim towards, dr dt, because these divide out. So what I'm going to do is I'm going to start by just finding the derivative, dr d theta, just finding the derivative of this. So derivative would be 6 cosine of 2 theta, like that. Okay, that is dr d theta, the derivative of this with chain rule. Then I multiply that by d theta dt, which of course is what I'm looking for. And that is equal to dr dt. Again, we found dr d theta by just saying find the derivative of this, like always. Multiply it by d theta dt right here. The d theta dt's divide out and leaves me with dr dt. My last step is to simply substitute everything in that I've been given. We're told the angle would be pi, so 2 times pi, d theta dt. The cosine of 2 pi is just 1, so I'm just going to kind of put it's 1. So I have 6 d theta dt equals -3. I'm going to divide both sides by 6, and you can see it's -1/2. So d theta dt is -1/2, like that. So again, this is my step-by-step process. DREADS, what I call it. Draw a picture. Write down the rates that you know and are trying to find out. Find an equation. Oftentimes with polars, it's simply being the curve that you were given that this thing is moving on. Then find the derivative. Oftentimes people just go straight to saying dr dt, and then they find the derivative and put the d theta dt on the end. Again, I just wrote this down as kind of a reason of why we're doing it. We found the derivative, and then we converted to the proper relationship that we wanted, which was with respect to time, and then we simply substituted everything in and solved. If this video helped you, please like and subscribe for more math help.